Hello! In this video we're going to start unpacking some of the concepts of programming that are valid not just for Python but actually for any programming language. You may have come across some programming before, maybe you've done some drag and drop style programming, whether it's Scratch or Blockly or anything else, and maybe you have experimented with running other people's code without actually knowing really how it works. What I want to do, and even if you know a little bit about programming or you're an expert, I would love you to watch through this video as I explain some of these fundamental principles, because I want you to see how I think about these things, and then I hope it might help you. Let's imagine we want to store a bit of information. Now, if I'm having a conversation with you and I ask you a question, then hopefully I'm listening for your answer. So if I say, "What's your name?" and you tell me what your name is, hopefully somewhere in my brain I'm going to remember that. Now, can't guarantee it, but I'm going to do my best to remember your name. The same needs to be true for a computer system. If we require our computer system to remember something, we're going to have to prepare it. We're going to have to create a little bit of space, literally a little bit of memory, we use the same word, to store and remember that answer to the question that we've just asked. So let's say that you have told me that your name is Fred. As a human, I want to remember that. I'm going to try and store it in my memory. A computer needs to do something special with it. Now, I might have a help. I just might jot that down on any scrap piece of paper. Here we go. I've just noted down that you told me your name was Fred. Maybe then I ask you how old you are. And then maybe you give me an answer. Maybe you give me a fun answer. Maybe you say you're 12.5 years old. Again, if I want to remember that, maybe I'm just going to note it down on a similar piece of paper. There we go. I've remembered that your name is Fred, and I've remembered that you've said that you are 12.5 years old. Now, these two types of information are actually quite different, aren't they? Because this is a name and this is a number. These are just characters, letters of the alphabet. This is something I can do some mathematics with. I can do some calculations. I could work out how much older I am than you. Don't think I want to know the answer to that one. So this and this are two different types of information. And it's really important that computers understand when we give them an answer what data type it is. Now, if you're going to give me a number answer, there's a couple of different ways that I can store it. Maybe you might give me the more conventional answer of saying that you're 12 years old. And if I store the number 12, then I'm going to put it on, for the sake of argument, this red piece of card here. So I can put the number 12 on here. If you tell me you're 12 and a half, 12.5 maybe, I'm going to put it on this pink piece of card. Now, they don't look very different, do they? And actually, they are almost identical, but they're not quite identical. When you tell me that you're 12 years old, I want to remember that, so I'm going to write it on this piece of paper. But now I need to remember, like, where this piece of paper is. I need to give it a label, because otherwise, if I've asked 100 people how old they are, then I'm going to have 100 identical pieces of paper with their answers written on. And that's not going to help me work out how old everybody is. I'm going to get them really mixed up. So I need to put this in some kind of container. Here's a container. It's a nice envelope, and I can put my piece of paper into the envelope. Now, this envelope hopefully is exactly the right size, she says, struggling to get it in. This envelope is exactly the right size to fit this red piece of paper, which is going to take a number like 12. I could label this envelope now, couldn't I? And I could say that this was Fred's age. I could give it a name, a label. If you've told me that you're 12 and a half, Let's see if I could put this one in. Now, look at that. Can you see? If I were to write 12.5 or 12.5 on this one, it doesn't fit in this envelope. This envelope is only suitable for whole numbers, or as we call them, integers. Have you come across that word before? An integer means a whole number, so it doesn't have a decimal point. If I want to store something like 12.5, then I'm going to need a different container. And this one is just the right size to hold my pink piece of card, which can hold a decimal number, or as we call it, a floating point number. There's lots of special floating point numbers that you'll come across in your studies of maths and science. I wonder if you know what this one is. How about this one? Maybe you've seen these numbers somewhere before. If we were to give this envelope a label, I'm going to put this one in here and I'm going to give it a label. So I'm going to write on the front what it is. Did you spot that this was pi? I'm going to label this envelope. This is what I'm going to label it as. I'm going to call it pi to 10 dp. That means pi to 10 decimal places. Can you see that I've used underscores in this variable name? This is because it's really important that we don't have any spaces in the names that we give to our containers. Now, I've accidentally used the word already. We don't call them containers. We don't call them envelopes. We actually call them variables. Why do we call them variables? Well, because the contents can vary. So I could take out my pi to 10 decimal places, and I could put in pi to 100 decimal places. Or I could put in this number here. Do you know what this one is? This one doesn't belong in a variable labelled pi, because actually this one belongs in this envelope. This is the square root of 2. So here's my name that I have given to this container. I want this envelope, this container, this variable to hold the root of 2, the square root of 2. 1.414, that's an approximation, but it will do for now. So I'm going to put 1.414 into my variable, and that is now going to store safely for me that value. So whenever I want to access that number, I can just ask my computer system, my Python program, can you see what's inside this envelope? What is this variable holding right now? What is inside it? What is its value? Now, I could have called this anything I wanted. I could have called it rhubarb. But rhubarb isn't a very sensible name. It's not going to help me remember that inside I've got the number 1.414. So when we give our variables names, it's really important that we give them a meaningful name. Otherwise, we're going to get all of our envelopes mixed up. Here's my other envelope that I just showed you before. This is my other variable. This contains pi to 10 decimal places. So both of these have got really sensible, useful names. That means that if I need to access what's inside of them, then I'm going to get the right ones. Now, do you remember I said that these are sometimes called floating point numbers? Because they've got a decimal point that floats around. It can appear anywhere in the number. This envelope is the perfect size to hold a float. A float is what we call this envelope, this container, this variable. This float is perfectly set up to store those numbers. Now, do you remember when I was talking about whole numbers before? Let's create a whole number container. Here it is. This is an integer, and an integer is another word for a whole number. The name I have given it is Hitchhiker's Answer. We quite often abbreviate things because we can't be bothered to spell the whole thing. This is the Hitchhiker's Answer. Does anyone know what I'm going to put in it? Well, if you've ever read The Hitchhiker's Guide to the Galaxy, then we are already best friends. If not, I really recommend them. Inside The Hitchhiker's Answer, we have got the number 42. 42 is the answer to life, the universe and everything. Or is it? You'd have to read the book to find out. Now this number 42, it belongs in that integer container. But the number 42 could also fit in my floating point envelope. So a float could also contain a number just like 42, but it might store it as 42.0. Yeah, same thing. My floating point number, however, 3.1415926,536, this is not able to fit inside my integer container. It just doesn't fit. It's too big. It's not going to fit. So these two number variables, my float and my integer, we use them fairly similarly, but they store different types of data, different numbers. So one of the things that I'd like you to do is to have a go at making some of these yourself. So you're probably going to need to pilfer some envelopes of different sizes to complete this project. Okay, so let's say we have now decided that we are going to save the age of somebody. Do you remember Fred? Maybe we're going to save that answer that Fred's given us in a floating point variable. So I'm going to save that information. I'm going to put it inside my floating point variable. That means that then if I want to refer to it again, if I want to print it out, if I want to use it in a calculation, then I can do so. And we'll look at how we do that in a moment. But now let's come back to the answer 42. Do you remember I said that this was a question, or the answer to a question? Here's my question. What is the answer to life, the universe, and everything? That's a really good question, isn't it? Now, you can see that this is not number information, is it? This is not going to fit in my floating point container. It's definitely not going to fit in my integer container. It's just not the right size. I need a different container to store this information. And I've got a nice envelope here. Here we go. Here's my new envelope. This is a new container. You can see that it's a different size. This is going to hold information like this, which might be something as simple as the word Fred, but actually it might be a really long string of characters like this. When we type on our computer systems, we can use our letters of the alphabet. We can also use numbers as part of something that we're typing in. We can use things like question marks and commas, and I put an ampersand in there as well. But there's all sorts of special symbols, aren't there, that we can use. Whenever we type something in to our computer system, it is converted into firstly an ASCII code or a Unicode, and then into binary. And we can just store the codes of all of those characters, and we picture them almost like a string of beads. We've got a string of characters that all are connected, and we remember the order in which each character was typed in. So this envelope that can just contain a string of characters, of key presses, whatever they are, they're not necessarily just letters of the alphabet. This is called a string. And this variable now is going to hold a string of all sorts of characters. We need to give it a name though, don't we? We need to label this envelope because maybe I might have more than one string involved in my Python program. I've called this the big question. You can see I've used an underscore again. Don't put spaces in your names of your variables because otherwise it won't work. So an underscore is quite a nice way to write out a lovely descriptive identifier for your variable. Now then, maybe you've never read Hitchhiker's Guide to the Galaxy. Maybe you might have some other answers. I've prepared some other answers and I would love to know what your answers might be to that big question. Here is another string with an answer in it. Let's see what this answer is. One ring to rule them all. I wonder whose answer that might be. When you create a name or a label for your envelopes, you are always free to choose whatever you want. Now, I've given this the name, the identifier of Gandalf's answer. But you might disagree. You might say, well, this is maybe Sauron's answer or Frodo's answer. If you're a Lord of the Rings fan, maybe you've not heard of that at all. Maybe you've got a completely different understanding of where that answer has come from. So whenever we create a label, it's your choice as to what you label it. So this is not one correct way of labelling this envelope. It's a way. It's my way. For today. Maybe tomorrow I'll choose something else. The important thing is that it is meaningful and it's helping me to remember what I've stored inside. Here is another answer. Doctor! What would you label that as? What name would you give that? The answer to life, the universe and everything is Doctor! Well, I've called this River's answer, as in River Song from Doctor Who. Maybe you've got a different idea, and that would be absolutely fine, that you created your own name, your own label for this envelope. So when we're creating these, everything that I've written in black on the fronts of the envelopes, all of these are your choice. There's not one right way to do it, but what we want to do is we want to try and make these as meaningful and as helpful as possible, so that when we come back to these variables in future and we end up with all sorts of, let me get all of them, we get many, many variables involved. So once we've got a whole load of envelopes going on, these are all of our variables that maybe we're going to be using in a computer program, then we need to know which one, which bit of information do I need? I need to pull out, oh, actually I need the root of 2 now. Or maybe I want to find the big question. Where's the big question? Oh, it's in here. So these names that we're giving them, naming our variables, is something which is so super important. I want you to begin to practice using some really nice variable names. Now, if typing is difficult for you, you might want to look at using a Python editor for doing your own Python programming called PyCharm, because there's a free version of that which has got some nice autocomplete functionality in there which will help you to type your variable names correctly. When we're programming together, then I will obviously always give you an opportunity to sort of pause and to create your own variable names. And if they're a little bit shorter than mine, then that's okay. But I'm going to just keep them nice and long and descriptive to help you understand what we're doing as we create lots of information. Oh, Arthur's answer. Arthur Dent. Arthur Dent was the last surviving human. He was part of the initial big computer which was created to work out the answer to life, the universe and everything. Arthur's answer is 42. But now look at this 42. This 42 has been stored as a string. Can you see that I've put speech marks around it? I put speech marks around all of the other strings that I showed you. 42 could also be written out like that. Now, those two bits of information for us as humans are the same. And actually, from the perspective of the computer, they're both just strings of key presses that we have put down on the keyboard here. And there's actually no difference from the computer's perspective as to the number version and the full written out version. This, on the other hand, what was this one? Well, this was stored as an integer. This was stored as a number. If I store the number 42 in number format, then I can do mathematics on it, and I can add numbers to it. For example, I could multiply it. I can save it as an integer, and I can do all sorts of different things to it. If I've just saved it as a string, I can't do any of those things. So it's really important that as we go through this course, we learn which variable to save it as, what data type is it. If I just type in the answer 42 and I press the number 4 and I press the number 2, then actually when I read in an input, until I tell it otherwise, Python assumes I've just typed in something like that. So when actually I read in an input and I want to turn it into a number, I need to tell Python explicitly, hey, I'm about to read in a number. Can you save it as a number format, please? So there's lots more that we're going to be looking at, and I hope my envelopes are helpful. Your challenge is to make some envelopes of your own. And I want you to create a string envelope, which should be nice and long, because we might have some nice long strings, questions, things going into those. Then I want you, if you can, to find 2 envelopes for your integer and your float. And your integer envelope needs to be just a little bit smaller than your float integer. So we can create a floating point number, piece of card that fits in the float, that won't quite fit into the integer one. There's one final envelope which I haven't introduced to you yet, and it's a super teeny tiny little envelope, actually, compared to the others. Here are the others. Here's a really, really tiny envelope. And inside this envelope, I can only have one of 2 values. I can either have, oops, get it right way up. I can either have the value of false, or I can have the value of true. These are the only 2 things that can fit in this envelope. They're very special values. And this little container, this little variable, is called a Boolean. And Boolean algebra is all about logic. It's about yes and no, true or false, 1 or 0, on or off. And that ties in very well, doesn't it, to our computer systems and our logic circuits, which we'll be looking at in this course, where either something is switched on, or it's switched off. It can't be halfway. So our Boolean data type is a very useful little variable because it can only hold one of those 2 values. And so maybe I might create a little Boolean variable that says, shall I carry on? Yes or no? True or false? So then maybe my program might repeat endlessly asking me a whole load of questions or taking in a whole load of input until I set carry on to false. Then maybe I stop what I'm doing. So these Boolean data types are going to be really useful. We're going to use them a lot to help control the flow of our programs as we make them, and we will encounter those as we go through the course together. So that's it for now. I hope you've enjoyed my little envelope explanation of variables and data types. As I say, these are valid for Python and for other programming languages as well. So it's a really useful concept to be able to understand and to explain to somebody else. Here's your challenge. See if you can explain this to maybe a parent or a family member who doesn't know anything about programming, and see how you fare. Good luck.